Example 1 for the shell method. As we begin this problem, they will give us a region to consider, and then they will tell us what to revolve about. In this case, it's going to say about the y-axis. So I want to figure out what region I'm dealing with. It says y equals 3 minus x squared. And so I come down here to my axes. 3 minus x squared is just a parabola that's 3 units up and opens downward. So my vertex would be here. I go right 1, down 1, right 2, down 4. And so I've got this parabola opening down like this. And then I have a second curve. Happens to be a line. It says y is equal to 3x minus 1. So I start 1 unit beneath the origin. Up 1, 2, 3, right 1. So I get this line. Looks like this. And they tell me to also consider x equals 0, which would be the y-axis. So it's this triangular region right here, this triangular region that they want me to revolve about the y-axis. So if I revolve this about the y-axis, this is what I'm looking at. Now, you got options. You can use the disk method, you could use a washer method, you could use a shell method. You got to see which is most appropriate. If I were to use a disk method, I would have to set this up with 2 different integrals. I would do an integral that would run from y equal -1 up here to y equal 2 and get that triangular region. Figure out what that would be. Everything would have to be in terms of y. And then I have to do, for a disk method, a second integral that would go from 2 to 3 that would consider the parabola. And so I could add those 2 volumes together. A little bit of work would be involved in that because I'd have to solve each of these equations for x, get everything in terms of y. It's doable, but I'd have to do 2 integrals, and I don't really want to do that, especially since it says shell method. So I want to show how to do the shell method. With the shell method, I'm going to say volume equals the integral, and what you have to remember for the shell method, your axis of revolution and your respect to which variable is going to be opposite. So if I'm going about a y-axis, I've learned that that should always be a dy, or y-axis is dy. For a shell method, it's all backwards. So I'm going to go from x equals 0 to x equal 1. Two pi, I have to establish what my radius is. You establish your radius by being egocentric. You are standing here on the y-axis, and you have to move to the right to find your region that is being revolved. And so as I go to the right, how far to the right I go? I don't know. Just somewhere to the right. And since as I go to the right, that would be considered a positive x. I'm just moving x units to the right. Then I have to establish, let me write this up here, I got 2 pi, radius, height, and then you have a depth, which is always d something. In this case, it's going to be a dx because we're going about the y-axis. My height would have to be the parabola minus the line. So my parabola minus the line. My parabola, I'm writing 3 minus x squared. Now listen, I know you can't see what I'm writing. Listen to what I say. I'm going to subtract this, so I'm going to write minus 3x plus 1. Because as you subtract this, you have to change the sign. You have to distribute that to both parts. So I wrote minus 3x plus 1 dx. And so now I can say my volume equals the integral from 0 to 1, 2 pi. And then I can simplify this and distribute the x across there. I'm going to do that in one shot here. I have my negative x and an x, which would be negative x cubed. I've got negative 3x times this x, which would be minus 3x squared. And then the 1 plus 3 is 4, and 4 times x would be plus 4x dx. Setting this problem up, if you were forced to do this without a calculator, it wouldn't be the end of the world because the integration is pretty simple here. If you're going to use your calculator, you just plug it right in and come up with your answer. I'm not that interested at this point in showing how to plug these into the calculator because we've done that in our previous lessons. I just want to show you how to set this up using that 2 pi r h dx concept, which is known as the shell method. So I look at my axis of revolution. I decide where I'm going. In this case, I needed to go to the right, so I just called that an x. And then I had established the height, which was going to be, in this case, top minus bottom, gave me my height. I simplified it right there. And then the depth of those would be a dx. Drawing these, I don't know if that necessarily helps or not, but you're talking about all these shells that you have in here. You're creating all these shells that are defined like this. And they just get stacked one on top of the other again and again and again until you fill that all out. And that is giving you a three-dimensional object. So there's our first example of the shell method.